Hey, we're going to be looking at table 4 today. So if you want to go ahead and get your notebook, go to the course calendar and click on notebook 4. We're going to be talking about table tools. All right, so again, pause and get notebook 4 open if you need to. And we're going to initialize first thing. And then we start with a review of arrays. Okay, so remember that make underscore array will take whatever's in parentheses. It'll make that list of numbers into an array. Sorry. Okay. And it'll take those numbers, and if I do heights, which is the name of the array, divided by 12, then it takes each of the numbers in the array and divides each of them by 12. Okay? Or I can do sum of the heights, and it'll add them all up, or the average of the heights. And why do I mention this? Well, please remember that it's important to note that if I have an array, I can do math, right? I can divide, multiply, add, subtract. I can take the sum of everything in the array. I can find the average in the array. So when I need to do mathematics, when I need to do mathematics, I need an array. Okay, so strings array. Now this, I'm not going to be able to do mathematics quite as easily, but I can have an array of strings. And notice that heights item 4 is 65. Let's see if we can get this right. So this is item 0, 67 is item 0. It starts counting at 0. This is 1, 2, 3, 4. Wait, what? Yeah, heights item 4. And please notice that we can use this in place of items. We can just use the brackets for, and it works. I almost always use this one. This will not work in certain cases. This always does. The dot items, it's the one I tend to use. Strings.array.item 0, notice that it starts counting at 0. Right, np.arange. So let's talk about this. This is one of the more important ones. All right. And again, it's not arrange. The English word arrange has 2 R's in it. This only has 1. Okay, np.arange. And let's remember what this does for us, okay? Sorry. Right, so np.arange 6, it's going to start counting at 0. It's going to count by ones, and it always stops one item before our stopping criteria of 6, and it creates an array. That's the cool thing. It creates an array of numbers that increase or decrease in a pattern. So if I put in a -1 as my increment, it'll count down from 15 to 7, but it'll stop 1 unit before 7, so it stops counting down at 8. Here it's going to count by 2s because that's the third or increment value. So it's going to count from 0 to 20 by 2s, except it'll stop 1 unit before 20. And here, this is crazy, but yes, it'll count by tenths if you need it to, always stopping 1 unit before the stopping criteria. Even though it does start right where we tell it to, it does stop 1 unit before. Okay, and what's np.arange 8? Well, I have 0, 1, 2, 3, 4, 5, 6, 7. And please notice that even though I start counting at 0, np.arange 8 does give me 8 items. So if I want 8 items, even though it stops 1 unit before the 8, it actually has the 0 in there. So it is, in fact, 8 items. And what is item 7? Well, it's the 7 here. Okay, right? Item 0 is here. Item 3 is actually the 4th number in the list because the computer starts counting at 0. Okay. So we have a couple different ways that we can create a table. We can create the table from scratch by using with column or with columns. The only difference here is that there is an S, okay? But with column or with columns, it does the same thing. It lets me put in the title of the column and then an array that's going to be the values in the column going down. These are a review. Remember, dot labels will just tell me the column names. Okay, and then number of columns does exactly that. It tells me the number of columns, and or it'll tell me the number of rows in the table. And please remember, whenever I need to import a data set into a table, I use table.read_table, and I give it the file name. Okay, so let's practice that. Okay, so notice we're going to make a table from scratch. We're going to start off with the streets, and we're going to use make_array, and we have 4 names of streets, okay? And we're going to use this table with open parentheses. Why? Well, we need a placeholder. This table is actually empty. Okay, and Southside is still empty. We want to name it something. So this is a placeholder for an empty table. And to the empty table, we're going to add 1 column. And I put in first the name of the column, which is streets. And then streets is going to be the array that has the data in it. And it's very cool. So this placeholder, it just took an empty table and then it added this 1 column to it. Okay, now Southside actually is this table. It has just 1 column called streets. And now it's saying I'm going to add a blocks from campus column. And it's going to add the numbers in the array np.arange 4, which remember will be 0, 1, 2, 3. Boom. Okay. Now this is weird. Even though I've added the column to it, when I call it, it still just has the streets. Why? Well, if I want it to be new, I have to name it Southside equals the Southside with column. That will make the Southside table change, right? The equal sign assigns Southside to be a new table, which is the old Southside plus a column. And like we said, Southside.labels, this will give me the names of all the columns in a table. Don't need it so much for a small table like Southside, but if there are 30 or 40 columns in a table, it can be really painful sometimes to try to scroll through and see all the columns. So dot labels is really good in a table with lots of columns to quickly get a list of what the columns are, and that way we'll at least know the names of the variables. Again, these are a little more important in much bigger tables, but number of rows, that will tell me how long the table is. This is the number of variables, and this is the number of responses in most data tables. And this is what I told you when we were looking at the PowerPoint. I can use table.readTable, and then I just put the name of where that data file is. I put the name of the file in quotes, okay? And this is the Dubois data set. Now, what is going on here? Well, class, this is socioeconomic status. And this is the actual average amount of money, okay? And this is just a name for the socioeconomic status. We have people who are poor, people who are fair, people who are comfortable, and also at the bottom, people who are well-to-do. So the socioeconomic status goes from lesser to more. Okay. Now, which class spent the highest percentage on rent? And by the way, I can look through the rent column and I can find, oh, this 300 to 400 class actually spent the most percentage-wise. This is a percent. Okay. Or I can use dot sort to get the same answer. I can use descending equals true, and that will put the largest percentage at the top. Okay, are they the ones who spend the most on food? Well, we'd have to actually multiply some percentages and see. Okay, now Dubois select status. Dot select just grabs whatever columns I name, and I only named 1. So Dubois dot select status just gives me a 1 column table. Now notice the difference here. This is extremely important, right? Because dot select gives me a 1 column table. But I can't do math with a table. So the dot column gives me the same thing, except that the output is an array. So I can use dot column, to get one column of the table out into an array where I can do math with it. Now, again, I'm not going to do too much math with a bunch of string variables, but it's what we use it for. That's why dot column is so important. And again, it's the same information, but it's built in array form. Okay. Then Dubois.column. See, here's where we use it. We want to add a column to our table called actual average. Okay, so this is the array that we're going to use. Boom. And we're going to add food. Excuse me, we're pulling out an array, actual average. And then we're pulling out an array, food, and then we're multiplying them together. And since they're from the same table, they're the same length. So what does it do? It actually just takes the first percentage times the first number. And then the second item percentage times the second item number, and so on. It does all of those. And it gives me an array called food dollars. Excuse me, it gives me an array. Sorry, it's right here. It creates an array. So food dollars is the name of the new array, which is, again, the percentage spent on food times the actual average. Okay. Now, Dubois is the new Dubois table is going to be the old Dubois table with the column. We're going to call it food with a $sign. And we're going to add the array food dollars to it. And here we go. What have we done? It doesn't seem like a lot, but it's taking the money times the percentage. So 43% of 139 must be about $59.81. And 47%, almost half, of $249.45, you can see there, is $117.24. Now, this is not incredibly important, but it is kind of cool. Notice this percent formatter. If I aim it at the food column, right, it's going to just make all of those decimal percents into whole number percentages with the percent sign. Okay, not the world's biggest deal. Remember, .select creates a table with the columns that I specify. So I specify 4 columns here, so I have a 4-column table. Okay, now what are we doing? Okay, so we're taking the food percentage out, but notice, even though the percent formatter turned these into whole number percentages, when I do this .column, what comes out? An array. And it's back in the decimal form of the number. So the percent formatter didn't change anything. It just made our numbers look prettier. I'm not saying it's unimportant. There are a few times this semester in class where we'll use that percent formatter, and it is really helpful. Okay, so selecting data in a column, we're going to enter the movies database, and this is movies by year with ticket price. Okay. Now, notice that this is number of movies, and the average ticket price in 2019 was $9.16, and the total gross. Okay. And notice what we're doing here. We're doing 1 e to the 6th. That is scientific notation for 10 raised to the 6th power. 1 times 10 raised to the 6th power. And we're able to find the actual gross in dollars. Okay. So we're going to do that. Our gross in dollars is the column total gross times 1 followed by 6 zeros. And then Ticks sold is going to be this array where it's gross in dollars divided by the average ticket price. And then I'm going to add another column to this table. Again, using the dot with column to add a column. The column name is tickets sold. And then ticks sold, which is the array we created up here, is this. And then look, we're using the number formatter. Again, not the world's biggest deal, but it's going to take this column and actually make it where we can see, oh, that's the number of tickets sold were 1.2 billion in 2019. Again, not just for this movie, that would be quite a deal. It's for all the movies. There were 1.2 billion tickets sold, and the number one movie that year in 2019 was Avengers Endgame. All right. And then we're plotting. We're using dot plot. What does dot plot do? Well, dot plot gives me a line plot. And along the x-axis is the first thing I list, which is year. You can see 1980, 1990, the year 2000, 2010, 2020. And then the number of tickets sold. And the question is, why does it look like this? Why does it look like this where it appears the peak, and I'm sorry, I'm trying to draw a straight vertical line. It looks like the peak is around here, around 2003, 2004. Why is the peak in 2003 and 2004, and why is it decreasing after that point? Did movies get less popular? And I hope you think about this for just a second. Maybe pause the video if you need to. But the answer is no. 2003, 2004, that's when video streaming services became more popular, right? That our modems got faster so that we could actually stream movies. More people had broadband. And so it's not that there was less movie seeing total. It's just that they shifted. These are all in the movie theaters tickets sold. And the reason there's a decrease is because there's a lot of movies that were being streamed at the time. So that helps explain what's going on there and why there was a decrease. Okay. This is really cool. Remember dot where? So we're going to do where the year numbers are between 2000 and 2005. Okay, so that's going to get these all between 2000 and 2005. And notice that it doesn't show 2005. Okay. And here, just the movies in the year 2002. And interestingly enough, in 2002, the number one movie was Spider-Man. Interesting. And I want you to, they're showing this. I've said this before, but when you just put in a number, right? You just say, hey, where the year is equal to 2002, it assumes that you mean r dot equal to. So as long as you mean r dot equal to, as long as you're saying, hey, I want the years that are equal to 2002, it will find them. Okay? And you don't have to actually type in the r dot equal underscore 2. You can just put in the number. The same works for strings. It will look for the thing that you want to see. And notice that the tables that it produces in these lines are identical. So the top one is just showing you a quicker way to sort of leave off the r dot equal underscore 2. Now this is interesting. Look at this, r dot containing Harry Potter. So any movie that contains Harry Potter in the title, where any year where the number one movie contains Harry Potter in the title, it's going to pull it up. Okay? And Deathly Hallows Part 2 was the number one movie in 2011. And the very first movie is Harry Potter and the Sorcerer's Stone, 2001. Oops, sorry. 2001. Okay. And then we can also do r dot containing Star Wars. Okay, so notice, so the dot where with the predicate r dot containing, it's going to pull up any movie, any number one movie that has Star Wars in it. Okay? But look at this. So why in the world are we putting this in? Well, it turns out that I can negate r dot containing and make it r dot not underscore containing. And this is true for all my predicates. I can use a not underscore in front of them. What's this going to do? Well, it won't let Phantom Menace show up. I don't know why in the world whoever created the notebook didn't want the Phantom Menace to show up anywhere, but this is going to show r dot containing Star Wars is going to grab all of the Star Wars movies, and it can be, notice that it can be anywhere, right? It doesn't have to just lead off. It can be in the middle of the title, or at the beginning, but it can't contain the word menace. Okay, and I don't know if Phantom Menace was one of the #1 movies. But we've excluded it, so it can't show up even if it would otherwise. Movies take np.arange 2 to 5. Okay, so what's this doing? This is grabbing the third row of the table, fourth, fifth, and stopping right there. So it's grabbing 3 rows of the table. Okay, why? Well, because this np.arange, right, is an array, 2, 3, 4. And dot take. So what does dot take do? Well, dot take goes into a table and it grabs 3 rows. Okay. And I have to go back up to where, man, way back up, right? It's going back up to the movies table and it's grabbing these rows out of the table, which are in fact oh man, now I've lost it. Which are in fact item 2, item 3, and item 4. Now remember, there's an item 0 in there, so it's actually the third, what we would think of as the third item, the fourth item, and the fifth item. Okay, movies take 9. Well, that's going to grab the 9th row, and it just pulls out the 9th row of the table. Okay, and we do know how to use movies show 5. It just shows the top 5 rows in the table. Okay, so just to pause for a second, we have gone over some important material here, and dot sort, dot select, dot column. Remember, dot column and dot select are very similar, except the output from select is a table, and the output from dot column is an array. So whenever I need to do mathematics, I pull the stuff out as an array using dot column. And dot drop and dot plot. And we talked about this one. It's really important to remember that table.read_table will actually load a table from a file. Okay. And we talked about some of the predicates for the .where method. R dot above is one, R dot below, R dot between, and then this R dot containing. And remember, we did not underscore containing, so we can negate these. And then dot take, we said, grabs a specific row or rows from the table. And again, we do have to remember that the computer starts counting at 0. It will be somewhat confusing sometimes when we're watching the computer count, but as long as we keep that in mind, we're good. So we're going to talk about the line plots using this table, and this table has some information from a recent census. And I want to make this point about the Pareto bar graph, because we do this a lot. We'll use the dot group, and after we group things, we'll sort them and then use bar H. And the Pareto bar graph just means that we make the bar graph from greatest down to least. We just sort it with descending equals true, so that the bar graph will have, the bars will be descending in size. Okay, so let's take a look at that. All right, so, sorry, let me get up here to I've got to go back up. Okay, so here we are starting the census table. It's called full, and it's got all these population estimates, and oh my. So from the full table, we're going to select 4 columns, and then we're going to group based on sex. Okay, so notice the counts. And then this is weird. Sex 0, sex 1, sex 2. Well, give me just a second. Okay, so let's show this. All right, so now remember, we're learning a new one here, relabeled. And so it'd say, hey, take the second column, which is this one, right? The 0 column is sex, and the first column, column 0 is sex, column 1 is age, and column 2 is 2010. And it's relabeling the second column as 2010. Why? Well, because this name is rather hard to deal with, right? So it's getting, instead of having this name, now we're using 2010. And instead of having population estimate 2014, it just calls that, this relabeled just changes the name to 2014, and it makes the table much easier to deal with. Okay. And notice that we're all dealing with sex 0. Okay, why? That's both of them, right? Let me show you. So we'll go back to the simple, sorted by age. Okay, so this 3.9 billion is the sum of, wait, is that billion or million? That's million. I'm sorry, 3.9 million in 2010 is the sum of the 2.01 million plus the 1.93 million. Okay, so sex 0 is both the biological sexes together, and 1 is males and 2 is females, okay? And while that is sexist, I didn't make the table, it wasn't me. And so you can see these things. So we have age 999. You're like, who in the world is 999 years old? Again, this is everybody. So we'll get rid of it in just a second. All right, and then this is why we drop the R dot below 999. We want to get rid of the 999. So the table called no 999 is everyone, right? Why? Because where sex equals 0, we're dropping, we're grabbing all the sex equals 0 rows. Why? Because we're getting a total. And then we're dropping the sex. Why? Well, we don't need the sex if we've chosen everyone. And this is a graph for this is a data display for 2010 and for 2014 of people as the years go by. So we have all the 1-year-olds in 2010, all the 2-year-olds. Okay. And why are the numbers getting bigger? Well, because we're adding to the population, right? So let's take a look at this everyone plot age 2010, 2014, and notice, let me go so you can see the age down here, right? And notice that we're staying pretty stable or even increasing a little bit up until about age 50. And then we have a down arrow. And the reason is rather morbid. I'm sorry about that. But yes, as people get older, the mortality rate increases. And so there are just fewer and fewer people at age 60 and 70 and 80 and so forth, okay? But this is just a dot plot, okay? And this is plotting the age 2014. We plotted 2010 just above. And by the way, they look almost identical. And we're actually going to plot both of them. So we have a table with 3 columns, 2010 and 2014, along with age. So this is plotting age, and it'll plot both of the columns. So 2014 is in yellow, 2010 is in blue, and they look almost identical. Why? Well, because the 20-year-olds here are 24 years old in 2014. So the yellow graph basically looks like a picture of the blue graph, but shifted 4 units to the right. Okay, does that make sense? All right, so just reminding you of how to use dot plot. It can give us some really nice graphs and help us understand what's going on with things like the population. All right, have a great day.